Hello, good morning and good evening to everyone. Welcome to Math Agility Live. This is our new platform where students can send in their math homeworks or problems to our social media channels, and we will answer them via Facebook Live every Tuesday and Thursday from 6 p.m. to 8 p.m. That's Pacific Standard Time. Wednesday and Friday, 9 a.m. To 11 a.m. Manila time. Those students who sent in their questions last Thursday or to Monday, Pacific Standard Time, or Friday and Tuesday Manila time, we will be answering those questions today. And tonight, actually, we have a special guest. So a brief introduction to our guest. He holds a degree in MSc Physics and BSc Mathematics, and is currently taking up his PhD in Renewable Energy, and he is now teaching at the Ateneo de Manila University in the Philippines. He also co-founded in a social enterprise focusing on clean energy access, especially to for marginalized Filipinos. And during his free time, he cooks and bakes, and also he do bikes and socializes. Please a warm welcome to Angelo Aquino. Welcome, Angelo, to Math Agility Live. I think you're muted, Angelo.
Hi, hello everyone. Good evening over there. Good morning to the guys here in the Philippines. Welcome to our Math Agility live session today, and I hope you will learn a lot and also enjoy math in the process.
Okay, thank you, Angelo. So let's start. So our first math problem is from John Roman of the Philippines. So let me share my screen to you. His question is in calculus actually, and it's about integration. Let me just give me a second. So this is the question. It says how to do integral of sine x ln of 1 plus sine x dx. So okay, let's write first uh, the integral of sine x ln of 1 plus sine x dx. So we can actually do the integral of this integrand through integration by parts. So integration by parts is actually multiplying uv minus integral of v du. So it's important that you know which variable we will assign to u and to v and to the integral of v du. So let's let u equal to 1 plus sine x. Therefore, du is equal to, of course, 1 would be gone. So cosine of x dx. And then for dv, which is our integral of v, so let's say dv is equal to integral of our sine of x dx. So v would be equal to negative cosine of x, right? So now we will have the form of the uv, which is 1 plus sine of x, and then multiply by negative cosine of x. So this is our u, this is the v variable, and then we have the integral of v, which is negative cosine of x, and then du is actually cosine of x dx, right? So let's simplify this expression. So let's distribute negative cosine x. So negative cosine of x minus cosine of x sine of x plus integral of cosine squared of x dx. So we already did the first part of the integral. However, we have a double argument or second degree trigonometric function at the end. So what we can do is either use a trigonometric table or we can use this identity. So there's an identity, trigonometric identity to be exact, which is equal to cosine squared x that will be equal to a double argument. So 1 half plus 1 half cosine of 2x dx. So let's transform our cosine squared x to this value here. Okay. Let me give. So let's copy the first part. Oh, sorry. So negative cosine of x minus cosine of x sine of x plus, now this would become 1 half plus 1 half cosine of 2x dx. And again, we can let u is equal to 2x. So du dx would be over 2 here. So again, copy the first part, cosine of x minus cosine of x sine of x plus integral of 1 half plus 1 half integral of 1 half cosine of u du, right? So u would be your 2x, your double argument, and then dx over du over 2 would be your dx, right? So 1 half, and then there's another 1 half outside, okay? So here is there's a double 2 over 2. So let's try to integrate the first one. So cosine of x minus cosine of x sine of x. This would become 1 half of x. And then this would be plus 1/4 sine of u. And then let's revert to, we did change to x to u. So let's revert back to the expression. Negative cosine of x sine x. And then plus 1 half x plus 1/4 sine of 2x plus c, right? Because this is an indefinite integral. So this will be the final answer for the integral of sine x ln of 1 plus sine x dx. Okay, all right. Hope you understand the process. And okay, let's go solving the second problem. Angelo would be solving this. Let me unshare first my screen. And the question, oh, sorry. I'm answering actually the question from Ian Almer from CLSU Philippines. So let me share again my screen. Sorry. So the next question is it says here using conditional proof, continue this formal proof of validity. So this is how I understand this problem. Okay. So A is, oops, A is biconditional to B. So let's try to see the truth table for the first part, and or and of C conditional to D, right? So let's create a truth table for A and B first. So this would be true true, false, and false. Of course, B is true, false. And A conditional B. So A conditional B means B implies A implies B. So this would only be false when A is true and B is false. So there's only one. It's in row two, right? That would only happen. So this would be false, and of course, otherwise the rest would be true, right? So true, true, and true. Okay, so we're done with the first part. Now let's do C um, conditional D. So let's take a space here. So C D. So C conditional D. So again, let's say C is T, T, F, and F, T, F, and T and T. So C conditional D. This would only happen when again C is true and D is false. So it's only false on the second row, so the rest would be true. Okay. And then getting the and or conjunction of the two. So let's say this part here and here, getting the conjunction of the one I've encircled, and so T and T would still give us T or true, right? F and F would give us again F, T and T would be T, and then T would also be T, right? So okay, so this is our answer for the first part. Let's do the second part, which is B. Okay, so let B and D conditional to A uh, conjunction of C. So let's say B is ND, and then B union or disjunction of D, right? So let's say this is true. Again, this is true, false, true, false, based on our initial truth table. And then D is also true, false, true, false. So disjunction would be OR. So anything with a T would be true. So true, false, true, and false, right? And then on the second part, so A is a conjunction of C. So let's try to put A and C here. So A would be your T, T, F, and F. Again, we defined that the C as T, T, F, and F as well. So conjunction would be at the first part, right? First row, I mean, second row, and then false, the third and the fourth row. Okay, and then combine this into a conditional statement. So let's draw the middle table. So combining B disjunction and A conjunction of C. So uh, so again, conditional to the first expression to the second expression would only happen when the first is true and the second is false. So that will only happen at the third row, which is here, and the rest would be true, right? So true, 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 false, true. So now combining this to the first result we got by taking one. Let's say this is let's say this is let's not call this one. So this would be 2. Our answer here would be 2, and this would be 1, right? So combining this 1 and 2 by 1 by condition to 2. So we have t, right? T, t, and t. So that's the first part. So now let's prove AC should be, now this time it's biconditional. So to C, so we said A is true, true, false, false, and C would be true, true, false, false as well. So biconditional happens, uh they they are true when both P, A and C would have the same true value. So since all of the rows have the same truth value, so this will all be true. So we have proven that this result and this result of A biconditional C is equal. Okay, I hope that helps. So let's move to the third problem. Uh, Again, I'm gonna solve this. So this is from this question is from Jocelyn. She's from grade 8 at San Francisco, California. And this is the problem. So gardening, it's a gardening problem. So Pakita has only 6 meters of fencing to use for enclosing her rectangular garden. She wants the garden to have the largest possible area given the sides of integral lengths. What are the dimensions of her garden? So there's a hint here that the perimeter is 2 length plus 2 width, and area is length times width. So okay, let's try to draw first. So our given our fencing is 16 meters. So this actually pertains to our perimeter, right? And then it mentions here that the sides have integral lengths. So integral lengths, or meaning it should be an integer, right? So it cannot have a decimal point. So when we draw the rectangle, it is L and W as mentioned in the hint. So it also says P equals 2L plus 2W. So let's try to equate this with the given 16 meters as the fencing. So 2L plus 2W equals 16. And let's solve L in terms of W. So let's try to transpose 2W to the right hand side. So L would be 16 minus 2W divided by 2. So 8 minus W would be equal to L. So let's name this as equation 1. Okay. And now for the area, so we know, is it also given in the question? Yeah, so area it says is A equals length times width, right? For a rectangle. So let's try to substitute equation 1, this equation, to the area, the expression of area, to the area formula. So let's move it a little here. Okay, L would be 8 minus W times W. So this would be 8W minus W squared. If you notice, our area formula or this expression is now a parabola, no? Because of the second degree variable of W here. So one way to do this, since it's I think it's an algebra question, it's not a calculus question. So let's try to solve this by graphing. Okay, so let's try opening my Desmos. So let's try to change A, our area, to Y equals 8x. So W would now become x and minus x squared. So where is our graph? Okay, this is our graph. Okay, this is, if we go into the vertex of this parabola, the highest point would be at the coordinate 416, meaning your width is 4 and the highest possible area would be 16. So let's go back to our bit paper. So uh, it says there width is 4, right? Hold on. We got the coordinate, which is the top of our parabola at 416, which is the highest point, right? And 16 is the highest, the largest possible value for the area, right? Which is your y in the graph for area. So if area is 16 and width is 4, then we can say L. So area is length times width, right? So this is 16 L and this is 4. So L would be equal to 4 as well. So this means that it could have a maximum possible area only if the shape is a square, right? So if this is L is 4, let's say, and this is width is 4 and not a rectangle. Okay, I think that's it. All right, so let's move on to the next question. So question number 4 is from Wesley. He is in grade 8 and he lives in Daly City, California. His question is about function. So if you can see on your screen, let's move this a little. So it says your f of x equals 3x plus 2 and gx equals to negative 2x. Find f of x if x equals 7 and x equals negative 4. And then find gx if x is 3 and x equals negative 5. So the first thing to do is we're just plugging in x equals 7 to f of x. So basically f of 7 is equal to 3 times 7 plus 2. So this is 21 plus 2. So this is 23. Now if we're trying to get f of negative 4, so similar thing, plug in negative 4 to the function plus 2. This is negative 12 plus 2. So this is negative 10, right? And then for gx, now this case, we're going to plug into g of x. So, oops. So g of x, oh, sorry, g of 3, right? So negative 2 times 3. So basically negative 6. And then g of negative 5 would be negative 2 times negative 5. So that is 10. So there's actually a follow-up question here. So h of x is equal to g of x minus f of x. So since our g of x is equal to negative 2x, right? And our f of x is 3 of x plus 2. So let's distribute, right? It's f 3x plus 2, yes. So let's distribute the negative uh, value of, there's a negative one. There's a hidden negative one here, right? So let's distribute that. So negative 3x minus 2. Combining like terms. So negative 5x minus 2. And therefore, this is h of x. And the last question is it says here find h of 4. So basically we will just again plug in 4 to the equation. So plug in 4, change your x into 4 and then minus 2. So negative 20 minus 2 is actually negative 22. All right. I think that's all. Okay, so I'll move now the so Angela would solve problem number 5, and this is a geometry question. So let me unshare my screen. Okay, Angela, you can uh,
Alright.
share your
Hello.
screen if you want.
So I'll just share my whiteboard first. All right. So the problem reads, the measure of the area of a square is 81 minus 90x plus 25x squared. So let's write that. The area is 81 minus 90x plus 25x squared, where x is a positive integer. Positive, important later on. Now we are being asked what is the smallest possible perimeter measure for this square. Smallest possible perimeter measure. So we can write first, rewrite A into a more familiar form where the highest degree is written first. That's 25x squared minus 90x plus 81, right? It's the same as the first thing. And we have to know that this is an area of the square. So with that in mind, um, we have to think that we can be able to factor this into um, factors and which will eventually multiply into an area. So this is actually 5x minus 9 quantity squared. Or you can write this as 5x minus 9 times 5x minus 9. So you already have a hint that one of these sides, one of the sides of the square will have a measure of 5x minus 9, right? So one side, one side of the square measures 5x minus 9, right? Now, what is the perimeter of a square? The perimeter of a square is only the sum of all the sides, the measures of all the sides. So that's gonna be 4 times this quantity, the length of one side. And that will be simplified to 20x minus 36, right? Now, we are being asked for the smallest possible value for the perimeter. Or what is the smallest possible perimeter measure? We have to note, we can do this um, because we have to note that x is a positive integer. So what are positive integers? That fact will help us. So the positive integers start from positive 1. So x can be any value from 1, 2, 3 onwards, right? So let's start with x equals 1. If x equals 1, your p will be 20 times 1 minus 36. And this will be negative 16, which is not a value that is valid for a perimeter of a square because a perimeter will have to be positive because the measure of a side is positive. Now, if x equals 2 on the other hand, the perimeter will be 20 times 2 minus 36, which will be 4. So actually, this will be your smallest possible perimeter value. Uh, if you substitute the next one, 3, that will give you 60 minus 36, which is 24, which is a bigger number than this. So therefore, this is your smallest perimeter value already. And as a bonus, one of the sides will be measuring 24 times 5 minus just one. Sorry, one of the sides will be one because if you multiply this by four, you will get four. Okay, that's it for this problem. I hope you got it.
Okay, so um thank you, Angelo. So for our next problem, this is from Kenneth. He's in grade 8, and he's from Daly City. So the problem is, let me share my screen to you. So let's solve. Let's see, we still have time. Okay, let's solve 48 and 52. Okay, so it says here, find all values of C so that each trinomial is a perfect square. So we know that a perfect square trinomial would have the form x plus a squared, right? Or x minus
Sir,
a.
question. Your screen is not shared.
Oh, sorry. Sorry. Okay, hold on. It's not sharing. Okay. Okay. Can you see my screen, Angelo?
Yes, sir. Yes, sir.
Okay. So so find all values of C so that each trinomial is a perfect square. So we're gonna answer number 48 and 52. And for a perfect square trinomial, it will have a form of x plus a squared or x minus a squared. So when you expand it, it would be x plus a times x plus a, right? Or x minus a, x minus a. So if the question says c n squared minus 220n plus 121, so we actually would form that this would have a square root of c n square root of c as well n here, and then square root of 121 is 11. So we actually don't know if the sign would be positive and negative, but we have a hint. If you look at the middle term of the trinomial, it's a negative, so we will put both negative here, right? So if we try to multiply the inners, so negative 11 square root of c times n, and that would actually be the same as the product of the outers, these two, right? Square root of c times n, and add them together. So if we add them together, that would give us negative 22 square root of cn. And actually, this sum should be equal to the middle term of the trinomial we're solving. So this negative 220n should be equal to this. So let's equate the two. So negative 22 square root of cn equals negative 220n. So n would cancel out, right? So let's try 22 square root of c and 220. And then let's divide this by negative 22. So square root of c would be equal to 10, right? Since we're trying to solve for c, we need to square both sides. So the square root sign or the radical sign would be eliminated when we square it. So this would be again become c, and 10 would be equal to 100. So our answer is c is equal to 100. Let's check if we got the correct answer. So is that 100? What's the original? Yeah, 100n squared minus 220n plus 121. Let's try to factor this out. It will give us a perfect square trinomial PST. So 10n here minus 11 minus 11. So If we try to get the product of the inners, this is negative 110n. Let's try to get as well the outers, the product of the outers, which is negative 110 as well, and add them together. This should give us the same as the middle term of our trinomial here, right? So if this is the same, then it means we got the correct uh, value for C, which is one. Is it 100? Yeah, C is 100. Okay, so we still have time. Let's solve the second number, which is number 52. So given, oops, 64x squared minus 16xy plus c, right? So let's try to set off the perfect square trinomial. So this would be x, 8x, sorry, 8x. And the last part would be square root of c, right? Square root of c. If we multiply the inners, so negative square root of c times 8x plus, of course, the outers would have the same value of negative square root of c times 8x. If we add them together, we will have negative 2, negative 2 square root of c, 8x, right? 8x. So this is multiplying it together, that is negative 16x square root of c, and this should be equal to the middle term, which is of our trinomial, which is negative 16xy. So negative 16xy. So negative 16 cancels out. Negative 16x cancels out. So square root of c is equal to y, right? So let's eliminate the radical sign by taking the square of both sides. So c is equal to y squared. So this is our answer. Let's check if we got the correct answer for this. So the trinomial is 64x squared. So we're checking it right now. 64x squared minus 16xy plus y squared, right? So let's try to factor it out. So 8x here. So y and y here, since we know that the middle term is a negative, so that's the sign we're going to use for y. And if we try to get the product of the inners, so negative 8xy, and the product of the outers, which is the same, and get the sum. So if we get the sum of these two, this should give us the middle term of our trinomial, right? So this means we got the correct answer for C, which is equal to y squared. All right, hope you get this. And let's move to our next problem. The next problem will be solved by Angelo. Let me unshare my screen first. So this is a physics problem. Let me stop sharing. Okay, Angelo, you can answer now problem number 7.
Hello. Hold on. Let me share my screen. Okay. So, um, sorry. This the one with the Doppler effect?
Yes,
Hello.
that's the one with the
Okay.
Doppler effect. Yes.
So for this problem, hold on. Let me read that again. For a physics lab experiment on the Doppler effect, students are taken to a racetrack. Let me copy this anyway. Let me
Do you want
copy.
me to share the screen first? Okay, you're doing it.
It's okay. All right. Let me just do this. Okay. And a car is fitted with a horn that emits a tone with a constant frequency of 500 hertz. And the goal of the experiment is for the students to observe the pitch or the frequency of the car's horn. Note that f sub d is equal to f sub c times this factor v plus or minus v sub d all over v plus minus v sub c. where f sub d is the wave's frequency at the detector, or sometimes we call it the listener. F sub c is the wave frequency at the car, or sometimes we call it f sub s, the source. V is the speed of the wave. V sub d is the speed of the detector or the listener. V sub c is the speed of the car or the source. Now, the choice of plus or minus in the equation must be determined based on the relative motion of the two objects. So I put some notes here on the upper left, which will help us determine the sign of the numerator and the denominator. So letter A, let's answer letter A. If a car drives at 50 meters per second directly away from the students who remain at rest, what frequency will they hear? And we have to note the speed of sound is 345 meters per second. So for letter A, let's put it here. V sub, uh, let's write the V sub C is equal to, hold on, I'm hearing, okay. V sub C is equal to 50, what happened? Sorry about that. V sub C is equal to 50 meters per second. And V sub D, since the students and the detector are at rest, that's zero. So we have to write the governing equation as F sub D is equal to V plus minus V sub D all over V plus minus V sub C times F sub C, right? Now, since the the car or the source is moving away from the students, we have to take note of the following, the notes in the upper right. So since the source is moving away, or at the same time it can be viewed as the listener is moving away from the source, which is the car, we have to use negative for the numerator. So this will be V minus V sub D. Right? Now on the other hand, for the denominator, the source is moving away from the listener, we have to use positive for that. So that would be V plus V sub C times F sub C. Now, what we just have to do right now is to plug in the values after determining the signs. So V is the speed of your car, which is the speed of sound in air. So that's 345. V sub D is 0, and then V plus C is 345 plus 50, and F sub C now is given to be 500, right? Or the frequency of the car. We can use our calculators later on to find out the value of this, and you will get it to be 436.7 hertz. So you can notice that it was a little bit reduced, which is what we would expect because the car is now moving away from the students, right? So I hope you got that for letter A. Now let's clear this and do letter B now. Um, where's my eraser? Sorry, I just have to erase this. Oh no, I cannot erase it now. Anyway, um, I'll just do letter B here. Okay. So would it make a difference if the car remained stationary and the students were driven in a separate vehicle at 50 meters per second away from the car? So Let's analyze that problem again. For letter B, we write again that the formula f sub d is equal to v plus minus v sub d all over v plus minus v sub c times f sub c, right? Now, if the car remains stationary, that means v sub c will be 0, right? And the students were driven in a separate vehicle at 50 meters per second means that your v sub d is equal to 50 now, 50 meters per second. Again, v sub c is the speed of the car, and v sub d is the speed of the detector or the listener. So in this case, for letter B, the students with the detector are moving away. So the roles interchange. Now again, we just have to factor in the different signs. So for the numerator, since the listener now here is moving away from the source, we have to use negative. Okay, so that's v minus v sub d. And for the denominator, the source is moving away from the listener, we have to use again the positive this time. V plus v sub c times fc. Now, we just have to substitute the given values. Again, 345 for v minus 50 all over 345 times 500. You will then be able to evaluate this value now for f sub d to be 427.53 hertz, which is a little bit different from what we got earlier for A, which was, hold on, earlier for A, we got this value, 436.7 hertz. Right, that is your f sub d for A. So these two values now are a little bit different. So it did make a difference if the car was the one that was stationary instead of the students. Okay, so let me clear that now again. Hold on, hold on, as I will um, check the rest of the question. Okay, I hope you can see this question now. So as the car drives by, the frequency, which is students here, f prime, is related to the car's horn frequency by the equation given as the following. F prime is equal to P all over V minus Vc cosine theta times F. Where V is the speed of sound, again, V sub C is the speed of the car, and theta is the angle shown in the diagram. So this is the diagram, okay, on the lower right. So the car is moving towards in this direction, towards the right. The students are here, stationary, and the car is here. And the car makes an angle theta with respect to the students here. So for this part, find f prime when theta is 60 degrees. All right, so it's just actually a substitution of the value. So let's see here. F prime is equal to V all over V minus PC cosine theta times F, right? So the given values are again VC is equal to 50, V is equal to 345. These are in meters per second, and F is 500 hertz. So we just have to substitute everything. So F prime is equal to V 345 over 345 minus 50 times the cosine of theta. If you get cosine of 60 degrees, you will get zero point 0.5 actually. So we note here cosine of 60 degrees is zero point 0.5. And then you multiply 500 here. So plugging everything in again, you will get 345 all over 320 times 500. And then you will get f prime will be 539.86 hertz. All right, so that's for part C. For part D, that's again, it's just a matter of substitution when theta now is 120 degrees. If you get cosine of 120, you will get negative zero point 0.5. All right. And after substitution, we'll just get, we're using the same values basically. So that's 345 all over 345. Now, but this time it's minus 50 times negative zero point 0.5. And then you multiply it by 500. Therefore, you will get f prime to be 466.21 hertz. So those are your two final answers for C and D respectively. Right? Okay. Now let's clear everything up for part E. So for part E, on the axis below, sketch the graph of f prime as a function of x, the horizontal position of the car relative to the student's location. So we have to take note that this is our diagram. So this is x, this is the x direction, positive x is going to the right, where and your students are at the origin. So this f prime is not a function of x yet. It's a function of theta, right? So we have to determine how to make f prime a function of x. From the diagram, so this is just a simplified version, right? This is your theta. If this is your x, this side of the triangle is your x, and this is your y, which is actually constant 40 meters. As you can see here in the diagram, it's constant 40 meters, right? So you have your x, your y, your theta. Now, we have to express your cosine theta here in this formula into x only, all right? So, for example, if we designate the hypotenuse as C, uh, we can um, evaluate C based on the Pythagorean theorem to be x squared plus y squared, right? Or x squared, square root of x squared plus 4t squared. Now, cosine theta can be expressed as adjacent side over the hypotenuse, right? So using our triangle, our adjacent side is x, and our hypotenuse is square root of x squared plus 4t squared, or square root of x squared plus 1600. Now we have everything in terms of x, which is what we wanted. So we can now write f prime is equal to v all over v minus vc times this expression now. X all over square root of x squared plus 1600 times f. Don't forget times f. All right. Now I think there's another question. So we have actually evaluated or expressed f prime in terms of x. Let's just simplify this so that we put um, hold on. Okay, hold on. Check the other question and sketch the graph. So we have to sketch it, right? So um, the graph. Okay, let's clear this first. Oh, sorry. I forgot to share. Okay, let's clear this. So again, let's write our expression for f prime to be times multiply by f, right? hmm I think, hold on. Let, let me think about this because I've already done this, but I might have a mistake because, but basically, we wanted to, all of these things, all of this outside x are just constants, right? So I want to express them as just a constant, for example, k. And I want to put this into another form, just moving this on the numerator. So everything will just be, your function will just look like this. So it's just a matter of expressing this, graphing this function, square root of x squared plus 1600 all over x. Now I have to use a program or a symbolic language program to graph this. But if you're familiar with the graph of this kind of function, um, it will look something like this. All right. So, and using just these values, you can label this. I think it's 1000, this is 0.5, and it's 1. So I'm just zooming in. This is negative 1000 and negative zero point 0.5 and then negative 1. So your graph will look something like this, like a hyperbola. All right. I hope that those things help you. Let us know if you have further questions from the previous um, part. Okay, I'll now stop sharing.
Okay, thanks, Angelo. If you have questions, you can type in actually your in the comment section of our Facebook or Facebook account. Okay. So now the next question is from Darren. Darren is already in college and he lives in Palo Alto, California. So this is the question. Let me share my screen. Okay, hope you can see my screen. So it says here, his first question is, you intend to estimate a population mean mu with the following samples. So these are the samples, these are your data. And then you believe the population is normally distributed. Find the 95% confidence interval for the population mean. Okay, so we're looking for CI at 95% confidence interval. Enter your answer as an open interval, means in parentheses accurate to two decimal places. So two decimal places. Okay, first and foremost, what we need to do is let's understand first that in this case, we will use a t distribution. So because the sample size n is less than 30, we only have 12 here. So n is 12, right? And then the second one, and the sigma, or the population standard deviation is not given, right? So this is not given from the problem. So on, we know that n is 12 and we have a normally distributed population. Okay, before we do the confidence interval calculation, we need to solve our sample mean, which is x bar, and this is equal to summation of xi from I1 up to n divided by n, where n is actually your number of samples, right? Or your sample size, which is 12. So to make it easier for us to compute, let's use our Excel sheet. Okay, let me insert this. Okay, okay, can you see my Excel sheet? So let's input the data that we have. So 14, oops, sorry. So 14, 18, 14, 17, 18, and then 14 again. Oops, 14, 13, 13, 11, 12, and then 16 and 13. So if you click equal and then say average, it will show you the word average, and then highlight on all the data that you have, and then it will give you your mean, which is 14.416. So let me just write it here on my. So our sample mean is 14.417. Now the second thing we need to compute is our standard deviation. So we also use Excel sheet for computing the standard deviation. So simply put equal and then stdev. So that means the standard deviation. And then again, highlight all the data that you have, click it, and then you'll see that it gives you the sample standard deviation to be 2.314. Okay. So what else do we need to do with Excel? Okay, let's go back to my whiteboard. Let me stop sharing my Excel sheet. Let's come back to my whiteboard. Okay, just give me a second. Okay, so I noted that our sample mean is 14.417, and then our sample standard deviation is 2.314. Okay, so if you want to do computing your standard sample standard deviation, you can use this formula: S equals square root of the summation of xi, which is your element or your sample, minus x bar, which is your sample mean squared, where I is from 1 up to n, and then divided by n minus 1. N is your sample size. So this means that you're gonna repeat summing the difference of the squares of your sample from 1 to 12, because you have 12 samples in this case. So now we have the two values. So let's compute Ci. So we're doing the 95% confidence interval for U. So the formula for CI, which is the we call this your not confidence interval, but your interval for the data we're looking at. So CI would be equal to X bar plus or minus the T star, which is your T value or test T statistics, S, which is your sample standard deviation divided by square root of N. So since we already know X bar, so this is 14.417 plus or minus, since we don't know yet our T bar, and S is actually 2.314, and then our square root of N is 12, right? Square root of 12. So let's try to solve first our T bar, our test statistics. So the T star value. Okay, how do we do this? So let's identify first our degrees of freedom. So degrees of freedom is n minus 1. So 12 minus 1, so that's 11. And then let's draw our normal distribution here, which is the bell curve, right? So if I put 95%, for example, here, so this is my 95%. So each of the two sides would have 2.5% and another 2.5% here. Okay. So where is T star here, or a critical value? Actually, the critical value is a cumulative value. So it starts from 0 up to here, up to this point. So this is your 97.5%. And your T star is on this end here, right? So this is your critical value. Okay, so again, we will use our Excel sheet to compute for the T star value, and this is actually T inverse of 97.5%, and the degrees of freedom df of 11. Okay, this will give us actually 2.201. So you just simply plug in this data, or this given data in Excel, and you will get E star, which is equal to 2.201. So now we have this value. Let's go back to our CI here. So let's plug in our T value. So 14.417 plus or minus 2.201 times 2.314 divided by square root of 12. This is equivalent to 14.417 plus or minus 1.43470. Sorry, 4704. So RCI is from 12.9466 and 15.8874. And in two decimal places, this would be, of course, let's round off. Our CI would be from 12.95 and 15.89. All right. Okay, so let's go to the next question. I think it's here. So it's a hypothesis test for a population mean where sigma is known. So we have a hint here already that if sigma is known, then we will use the z value and not the t distribution, right? Okay, so let's start. So let's read the problem. You wish to test the following claim h of a, which is the alternative, at a significant level of 0.05, where h of o, so your null hypothesis mu, is equal to 77.3, and h of a mu, which is not equal to 77.3. So this means that we have a two-tailed test, right? Two-tailed test. You believe that the population is normally distributed, and you know that the standard deviation sigma is 12.7. So we have sigma, which is 12.7. What you obtain a sample mean of m equals 75.3. So that's actually your x bar, right? 75.3. For a sample size of n equals 26, so sigma is 12.7. What is the test statistic for this sample? Report answer accurate to 3 decimal places. And what is the p-value for the sample? You have to report it in 4 decimal places. So let's write everything we have. So we have a significance level of alpha of 0.05. So alpha is 0.05. And of course, this is our null hypothesis of HO mu equals 77.3, and mu not alternative hypothesis at mu equals not equal to 77.3. And then we have the sigma, we have the x bar, we have the n. So the test statistic formula is equal to z equals x bar minus mu all over sigma square root of n, right? So to solve this is equivalent to 75.3. Our mu is 77.3 divided by 12.7 square root of 26, which is our sample size, right? And we will, if you're gonna compute this will be negative 0.803, right? So this is our test statistic. And if we try to draw the curve, the bell curve, so this is our two-tailed test. So our mean, or our mean of our population, is in the middle. So here, where mu is 77.3, and our sample mean is on this side, which is x bar at 75.3. So let's try to shade this part here. All right, so let's compute now the standard deviation of our sample, which is sigma subscript x bar, right? So which is sigma over square root of n. So our population standard deviation 12.7 divided by square root of 26, which is 2.4907. Okay. So now again, we will gonna use Excel. So let me show you how you compute the normal distribution uh, value. So let me unshare this. Let's go to Excel. Oops. Okay, this is Excel. So just click equals and then normal this. So that means normal distribution. And then X would be your X bar, which is, what's the value of this? 75.3. And then put a comma, and then your mean is your mean population, which is 77.3. And then comma again, your standard deviation of your sample, sigma sub x, sigma sub x bar, right? So that is 2.4907. And then we type through because this is a cumulative value. So then you will get a value of So our normal distribution value. So that's the area of this part here. So that's 0.210991. So okay, I just copy it. Let's again go back to my whiteboard and let me share my screen. Okay, so this is the value that we get for the normal distribution. And basically this is the shaded part here. So that's our normal distribution value or the oops or the area or the probability. It's the same. So now to get the p-value, since we have a two-tailed test, so simply multiply this two shaded part. So 2 times 0.21099. That would give us a p-value of 0.42198. Okay, so if we go back to the question, I think there's a follow-up question in the here. Okay, so this part here says the p-value is, since our significance level is 0.05, therefore our p-value of 0.2198 is greater than 0.05. So our answer here is letter B. And then this test statistic leads to a decision to, of course, if p-value is greater than our significance level, our answer should be fail to reject the null, right? Letter C. As such, the final conclusion is that, okay, since I've already read this, there is not sufficient sample evidence to support the claim, which is D, that the population mean is not equal to 77.3. So there's not sufficient sample evidence to support the claim, all right? So that's letter D. All right, so if you have questions on this, you can type in at the comment section. And I think the last problem will be answered again by Angelo. Okay, let me unshare my screen and give you to Angelo.
So, okay, let me share my screen once again. So, um, this is a physics problem, and we have this diagram about electric charges, fields. Um, we're given the two charges, positive capital Q and positive big two two Q, are fixed in place along the y-axis of an xy coordinate system as shown in this figure on your left. Charge 1 is positive Q, charge 2 is positive 2Q, and they are located in point. We're being asked for the first question, what finds the electric force, the magnitude and direction felt by charge 1 due to charge 2. For part A, we're being asked to find the force. Okay, the electric force can be written as F is equal to K times Q1 times Q2 whole over R squared, where Q1 and Q2 are the two charges, and R squared is the distance between them, and K is a constant with a value of 8.99 times 10 to the 9 Newton squared per coulomb squared. But we don't actually need to plug in this K value, we just need to retain it as K. So the force felt by charge 1 due to charge 2, or F sub 1, 2, therefore K times Q1, which is capital Q, Q2 is capital 2Q, all over the distance between them. But the distance between them is just A and 2A. So that will be 3A or R squared. So we just have to simplify that. We will get, oh, sorry, K So this is the electric force magnitude felt by charge 1 due to charge 2. This expression. However, we're being asked as well, what is the direction? And we have to take note that both of these are positive charges. Therefore, they will repel each other, right? Like charges repel each other. So positive 2q charge is force 2. It's like being pushed downwards, and positive q charge here is being forced upwards. So the direction of the force felt by charge 1 is upward. All right. So for letter B, we are being asked to find the electric field this time, not the force. And the electric field is also a vector, which has a magnitude and direction. So find the electric field at the origin created by both charges 1 and 2. Now, electric field in general can be written as E is equal to KQ over R squared. Right? So it's just like your force divided by test charge, something like that. So your electric field due to the first charge is KQ all over. We have to note that we are being asked about the field at the origin. Okay. So at the origin, the distance from Q, the first charge to the origin is just A squared. And the electric field, we have to remember, it's like it emanates from the positive charges going outwards, something like this. So from the first charge, Q1, this is directed downwards, downwards. Therefore, we have to put a negative sign here. Okay, so that is the magnitude of the first electric field due to the first charge. The electric field due to the second charge this time is E sub 2 K times 2Q all over our radius now this time is 2A squared, right? And simplifying this, we will get KQ all over 2A squared. But this time it is pointed upwards because your field lines will be going in this direction, right? So the electric field in the origin due to the second charge will be pointed upwards. So it will just be positive to retain this. Now the total electric field along Y, put it here, E total is just the sum along Y. This is just a simple sum because it's just measured along Y. But this is not always the formula that will apply. This is just along Y. So the E total is just the sum negative KQ over A squared plus KQ over all over 2A squared. Alright? And that will give you negative 1/2 KQ all over A squared. This is your electric field total in at the origin due to the suitable charges. All right. For letter C, I hope you got that and um, save this as well. So for letter C, I'll erase all the annotation here. So let's solve letter C. What we're being asked, is there a point on the x-axis where the total electric field is zero? If so, where? If not, explain briefly. So as again, let's draw the electric field lines radiating outwards from the charges, from the two charges, for example. So you can see that they are radiating outwards, and since they are positive, they are radiating outwards in all directions. And again, we have to take note that the electric field has the equation something kq over r squared. All right. Now, these are both positive charges, and um, the electric field extends indefinitely. So, is there a point you have to ask yourself? Is there a point where this expression becomes zero? Um, Basically, you can think of it as not. No, there is no point where this is zero unless your r squared is infinity. Okay, so there in the real number line in this diagram, there is no point along the x-axis where this will be zero. And even if you combine them, they are both positive charges, so they won't cancel each other. So there is no point. So again, so E1, for example, E1, the electric field to the charge one is KQ all over A squared, which is negative, no, positive, sorry, along the, R squared, because this is a arbitrary point along the x-axis. E2 is now 2KQ all over R squared. So if we sum these two electric fields, there is no point along the x-axis, no point along x-axis where both will be zero, where the total electric field is zero. Okay. Now for letter D, we're being asked is there a point on the y-axis now where the total electric field is zero. We can also think of it like the same way we thought about part C, and again there is nowhere along the y-axis, nowhere along y-axis where electric field is zero. You might think that uh, when r is zero, this will be zero, like in the point themselves. But in that is not the case. And even if, for example, we take the position of q here, first charge, and consider it a point, and that point will still feel or detect the electric field due to the second charge. So there is nowhere along the y-axis where the field is zero. Now for part E, if a small negative charge, negative q, and mass m were placed at the origin, determine its initial acceleration. Okay, so this is an interesting problem. If we put negative q, let's draw this again. You have q here, you have negative q, and then you have 2q here, right? So negative charged particles will be attracted to the positively charged particles, right? So the forces will be directed along this line. So from the force felt by negative small q due to positive big Q here will be directed upwards, and it will be downwards for the other charge. Um, we can write now F of the first small charge Q or negative Q due to 1 is equal to K times negative Q times Q all over A squared. Alright, correct? And you simplify that to be negative K Q Q all over a squared. The force felt by the charge due to the second big charge is K. hmm, Wait, hold on. Okay, sorry. This has to be just the magnitude. So this will be positive. So this will be positive. But it is directed upwards. Okay. This is just the magnitude that we are talking about. In this second for the second charge, it's KQ times 2Q all over 4A squared. But this time it is directed downwards, so there is a negative sign here. All right. Now the total force along the y-axis, this is easier to solve because it's just along one line along the y-axis. It's just the sum of these two forces along y, and that will give you k q q capital Q all of a squared minus or plus negative kq all over 2a squared. I just simplified this term already, and that will give you a positive kq q all over 2a squared. So a positive force means that it is being the test charge small q is being directed upwards, which makes sense because it's very much closer to the charge positive q here on top. Right? Now the total we are being asked actually to determine its acceleration. So not just the force, but acceleration is just F all over m from Newton's law. All right. Let's use capital A for acceleration because we already have small a variable. So capital A is equal to F all over m, and then we'll just plug in this KQQ all over 2 times m a squared. And you have this value now for your acceleration, where a there is the coordinate of the charges, positive q. And the direction of this is upward because it's directed in the same direction as the total force. All right. I hope you understood that. And if you have any questions, let us know. Thank you.
All right. Thank you, Angelo. Actually, the last question was from Henry, grade 12 of Daily City. We forgot to mention that earlier. And do you have any parting words, Angelo, to our viewers?
Um, Hello, for all the students out there. I hope you learned something new today, and we hope that you continue to be diligent with your studies and continue asking questions. Yeah.
All right. Thank you, Angelo. And okay, there you go. Thank you for watching us today at Math Agility Live. Thank you, Angelo, for joining me tonight and sharing your expertise in solving the physics problem. And to all our followers who send in their questions from Monday to Wednesday, that is Pacific Standard Time, or Tuesday to Thursday in Manila, we will be solving them via Facebook Live again on Thursday, March 25, Friday, March 26 in Manila, and hope to see you next week or see you next time this coming Thursday. And God bless everyone and stay safe.